Good morning, dear students. Today we start our course on molecular spectroscopy. I am your instructor. My name is Dr. Lijankia John, and this is the syllabus that we are going to follow. And this is the syllabus that is molecular spectra, and the reference text is Modern Physics by G. Aruldas and P. Rajgopal, and this is the text, and we will follow this textbook. So we start our course, and today is the first session, and today we will cover electromagnetic spectrum, molecular energies, and classification of molecules. So molecular spectroscopy. What is molecular spectroscopy? We all know molecular spectroscopy means it's an interaction of matter with electromagnetic waves. By analyzing, this gives the spectrum gives the information about molecular structure, the bond length, bond angle, strength, energy levels, etc. So next, that is the interaction of matter with electromagnetic waves. So in the interaction of which interaction of this matter with which electromagnetic radiation will result into the molecular spectroscopy, that we need to check. That is, this is an electromagnetic spectrum from top to bottom. We can see that the spectrum is wavelengths are in the increasing order of wavelength is shown in the spectrum, and we can see that in the microwave spectrum, that is the microwave region will result into the rotational motion of the molecule, and the infrared transition will result into the molecular vibrations, that is vibrational spectroscopy of the molecule, and the near UV or the visible transition will result into the electronic transitions. And in spectroscopy, generally we will represent the radiation, the electromagnetic wave, in terms of their wave number, that is 1 by lambda, that is equal to nu by c. So it's the unit is usually we are using as centimeter inverse. So the spectral region for molecular spectroscopy is in these three regions, that is the UV visible region, and infrared region, and the microwave region. So what is the molecular energies? We know energy can be stored either as potential energy or kinetic energy in a variety of ways. Okay, that is, the first one is the translational energy, that is a small amount of energy stored as kinetic energy. The rotational energy is the kinetic energy associated with the rotational motion of molecules about center of mass, and that is the molecule kinetic energy associated with the rotational motion of molecules. And the third one is the vibrational energy. These are the oscillatory motion of atoms or group of atoms within a molecule. The last one is the electronic energy, that is due to motion of electrons in the molecule, and we can see in this figure, we can see that both the rotational and vibrational motion is shown in this figure, and this results in rotational vibrational spectrum. And Born-Oppenheimer approximation, which Born-Oppenheimer assumes that all these energies are all the molecular energies are independent. That is, we can write in energy of the molecule is equal to, that is the sum of the translational, rotational, vibrational, and electronic energy. Of these, all except the translational energy are quantized. So this is the figure of the molecular energy levels, and we can see that this blue levels indicate the electronic energy states, and the green lines indicate the vibrational energy states, and this brown level indicates the rotational energy levels. We can see these rotational energies are, the spacing between these rotational energies is very small when compared to the vibrational, which is again small when compared to the electronic energy level. That is, the spacing is largest for this electronic energy state. So in an electronic energy state, there are so many vibrational levels, and in a vibrational level, we can see that so many rotational levels. So this is all about today's session, that is about the molecular energy levels and the electromagnetic spectrum. Hope you all understand, and